Thanks, Sal.
You got it. All right, guys. Thanks for watching, everybody. We have much more news coming up on the other side of the script. We hope you'll stick around. We'll see you.
At 11 is all the late-breaking stories, live reports, and new video from the Sacramento area's most trusted news team.
Hi, Phil.
Look at all these handsome people.
Where?
Oh,
How are you?
All right.
How's the squirrel zapper?
I haven't yet to kill these squirrels. No squirrels have been sacrificed.
Oh, darn. I was hoping.
let me see. Well, 8 participants, okay. People don't know how to operate.
Well, thank you, Bob, for trying to straighten things out on the group's website.
Well, you still have the menu problem, right?
Yeah. Well, am I the only one who uses the Mac around here?
I use a Mac.
You use the Mac?
Hi, Phil.
You have no problem of opening the files in the IO group?
Well, hey, Rookie, I also have a PC, so I've been using that to open the files, so I don't know whether the Mac will or not.
Okay.
Every department. Now that we're spending more time at home, comfort really counts. Take advantage of incredible deals on recliners, mattresses, and more. We have dozens of dining and bedroom sets to choose from.
Hey, Rick.
Somebody's selling bedroom sets.
Yeah, Rick is watching TV, I guess.
You see interference?
Kill your audio, Rick.
Sale at RC Willie.
Oh, I'm sorry about that.
That's much better, yeah.
Hello, everyone.
How we doing?
Good evening, guys.
Hey, good evening to
Hello,
everyone.
Neil, is your rig working?
Yes, like a champ.
Cool.
Yeah, it's your fault too. I
Oh,
remember
good.
that.
I love to be to blame.
Thank you, sir. It worked like a champ.
My wife depends upon it.
I already tried CW, tried FT8, and tried everything, and it works like a champ. And the time is still standing on.
That's one little tiny battery.
I've never seen one that small.
Hello, Bob.
There's John.
Hello, Phil.
How we doing?
Good. So far, so good.
I love the sound of that. You know, that's what the skydiver said when he forgot his parachute.
Jump out of the plane. How's it going? So far, so good.
So far, so good.
And
Have
then
you
he
ever
tried.
done that? You ever jumped out of an airplane?
I have.
That's pretty cool, isn't it?
It is. I tell my kids, anything like skydiving or whatever, you have to try it 3 times. The first time, you're so scared you don't know what to do. The second time, you kind of figure out how to do things, you're still scared. And the third time, at least you overcome the fear, you know how to deal with the shoot and what to expect, and now you can decide whether you like it or not.
Well,
And then the fourth time, you usually perish.
Well, in my case, in my case, when I tried it, my wife explained to me that if I ever did it again, I wouldn't live to think about it.
Oh, there you go.
well,
Well, it was a one-time deal for me, but it was still pretty darn cool.
So when are we doing it, Phil?
When are we doing it?
well,
I'm ready.
I did it 13 times when I was young and immortal, and I'm neither anymore. So, but I was scared every time, all 13 times.
Huh.
And,
John, I've bored Bob mixed to death with these stories, but in my younger days, I used to flat track motorcycle race.
Oh yeah.
And the scariest thing to me is riding a bicycle. You have no horsepower. You got these little tiny tires, and one little pebble will put you on your head. So the skydiving thing, you know, that's okay.
That's
You know,
good. That's
but
good.
being fearful is still part of the thing, you know. And you forgot the other part of the joke of the skydiver. He jumped with 2 parachutes. The first one failed, and he said, "Okay, I'll try the second one." He went for the reserve, and that one failed. And he says, "Okay, with my luck, the truck won't be down there waiting for me."
Yeah, there you go.
Yeah, Phil, the only thing I'm afraid of is hitting a 1 iron off the first tee box.
Oh, well, you're going to have to join us. Because none of us carry a 1 iron.
Exactly.
And all my clubs, I go the same distance, 100 yards. That's it.
Hey guys, I'm going to start talking because we only get like 40 minutes if we're lucky. So I'll launch into it. Today, we should talk about assembling the rig. I don't know how many people are assembling. I sent out a little poll thing to ask you, are you soldering anything yet? But whether or not, we'll talk about it. Out in the files folder under Tuna 10S, there are a number of files. Phil has a file called Tuna 10 Build Notes and Errata, and he's got lots of clues in there and thoughts about building this rig, and a table that shows the number of turns for each of the 4 inductors for 3 different bands. So you have to pick a band and follow the table for the band. And so Phil has one, and then I also have one out there. We weren't going to write a manual. We were going to try to talk everybody through it using Zoom, but then we each wrote up some notes. And this is my document. Talk about some of the things you're going to need to build it. And then I think you should start with the digital part of things. You can get a lot done in the digital area with very little soldering, other than headers on parts. So anyway, this document's out there. The Nano comes in a little package like this. You have 2 15-pin headers.
We don't see what you're showing.
Oh, that's right. I have to share the screen. Yeah. I don't work well in this Zoom environment here, so I'm going to share my screen.
I thought you just didn't share well with others.
Well, it works that way too.
We got a full house. There's 15, 16.
Do you see my document now?
No.
No.
No?
Well, do you have the package? You can hold it up?
No.
I do. I'll go get it.
Oh, here it is. I guess I have to do this and share this maybe. You see it now?
There you go. Well, it's starting.
Yep.
You got it. You're good
Hey,
to go.
That's a picture of the Nano package, right?
Yep.
That's what you see? Okay.
That's what we see.
So you need to solder these headers onto the Nano. The long end goes down and the short end pokes out of the top on both sides.
Which one's the top, Bob?
The top, as I've written in the document here, the top is the part that has the square microcontroller and the USB connector there. So
Good to know.
it says that right there. And in order to get the headers on, you want them at a right angle. You want to be sure that they can fit into the sockets that are going to be soldered to the board. So that's a little bit of a problem. If you just start soldering,
When Hank and I were building things that use those kind of connectors, we used the board as a jig, plugged it in, put the device on that needed to be soldered first and found that it acted as a jig to make everything line up properly.
Right.
That's exactly right. Good
I
idea.
actually mentioned here that you might want to, plug these headers into a socket and then solder them to the Nano. I don't like the idea of having a lot of heat going down into the socket, but that may be the best way to do it. So anyway, that's part of the adventure of building anything. Is there are lots of different ways to do it, and one way will work well for you, but not work well for somebody else. So there's a certain amount of creativity and Yankee ingenuity involved in this. So anyway.
Yeah, you can tag the four corners and get it all squared up and then set it out of the board and finish your soldering so that you're not putting heat into the board.
Yeah. What I do is just solder one pin and then see how squared up it is. And I can, reheat that one pin and move it a little bit until it's right. Once I got it in place, then I solder them all one after another. So.
Yeah, that's what I'm talking about. Just getting it nice and square and then going for it.
Okay. And then what I think you should do after getting the Nano together and plug in the USB cable and do the upload like we explained in a previous session, is to set it aside and get some power to the board. So I think you should assemble the 9-volt power section. And it's mentioned here in item number 2. It only requires the DC jack, 3 capacitors, and the 78L09, also called U2. It's a voltage regulator. You solder that into the board. So there's some verbiage here. I'm not going to read it out loud. And then for those of you who actually are not scared by looking at a schematic, I have that. Can you see the schematic now?
No.
No.
Yeah, we're still seeing the list.
Okay.
A question, Phil, you indicated last time that schematic was not correct. Is this a new version?
There are 2 schematics. You want the one with a later date.
Okay.
And Bob, I have a question about the pins on the Nano. In the errata, there's mention of cutting off a pin on the header or something. I've looked at mine closely and I can't find anything that needs cutting off.
These sockets, the 16-pin sockets, you don't need 16 pins. You only need 15. So in order to solder the 16-pin socket into 15 holes, you cut off one of the pins.
Yeah, that's on the Tuna tin board, not the Nano.
I'll take a look again. I like Gert was suggesting, I used the board and the headers as a jig and everything went in precisely. I haven't soldered it yet, but there's nothing that gets in the way of the Nano going in.
Yeah, but you've got 2 16-pin sockets to go in the Nano board that are in the Tuna tin board that the Nano plugs into. And it's those sockets that each have an extra pin.
Okay. So they're stacked.
No, the Nano plugs into a socket.
Two sockets.
The sockets that have an extra pin.
Whoa. Okay.
Yeah.
Okay, this isn't just using the board, you're actually using the socket.
Yes.
Okay.
There's a reason for that.
Among other things, you can unplug it.
And replace it when you blow it.
Yeah, we know how that works.
I've already blown up one, but what they're talking about is right here. You have the socket.
Yeah.
And the socket it has one extra pin, so you got to cut it off.
Oh, so
And
the socket's too long.
The socket's too long, and that way the Nano can plug in correctly.
Okay.
Hey, Phil, is there any chance of using those plug-in sockets for the toys so that you can replace the bands?
Well, you'd have to do both the torids and the capacitors.
Correct.
The whole bandpass
So
filter.
the answer to your question is, you can actually buy little pins that you can do that with.
Okay.
There's none included with our kit.
Okay, no problem.
Following up for just a minute,
There's your schematic.
I've got the Nano plugged right into the board. I have not put this other header in. Where'd it go here? That needs to be inserted apparently, and that's the one that has.
Yeah, you have the Nano soldered into the board?
It's just resting in there. I haven't soldered anything.
Oh, okay. Well, you want to solder the sockets into the board, and then the Nano plugs into those two sockets.
Okay.
Bob, you've got the old schematic up on the screen.
Oh, fine.
That's just a single pole double throw relay. It doesn't have a mute function.
Okay. Well, all I was going to do is talk about the power section, so that hasn't changed, I don't believe. So.
No, it's still the same.
Okay. What I was going to say about the schematic is that the DC power jack on the schematic is right up here. And connected to that is a capacitor here. Everybody see me circling the part?
Yes.
Yes.
Okay. So you solder in the DC power jack, you solder in this capacitor, you solder in this capacitor, you solder in this capacitor, and then you solder in this part, which we call U2, and it's an L78LO9. This says 8, but it's a 9, right, Phil?
I believe so, yes.
Yeah, it's a 9-volt regulator. Once you have that, the output of this regulator comes down here and follows this line all the way over to the Nano, to the last pin on the Nano, the upper left-hand pin on the Nano, and that supplies power to the Nano. The Nano then has its own regulator, and it breaks that 9 volts down to 5 volts. And the 5 volt comes here and it goes off, and it supplies power to the other digital parts, which is the display and the SI5351 clock generator. So by soldering in just those few parts, 3 capacitors, a regulator, a DC jack, then you've got power to the Nano, and you can plug the Nano into the board. And then if you supply power to the DC jack, you'll have power to the Nano, and you can see the power light come on the Nano. And then
what
yes.
voltage is the wall wart? Is it a 5 volt or a 9 volt wall wart?
It can be up to 16 volts if you want.
Okay. At least 5.
If it's
well, you're going to want at least 12. Otherwise, your transistor, your output transistor, doesn't have enough oomph to put out much of a signal.
Where do you get the 5 volts from?
It comes off the Nano actually produces 5 volts.
Oh, okay.
We feed it with 8 or 9, and it's got an onboard regulator that creates the 5.
So Bob, one correction, those regulators can take an input voltage almost as high as 25 volts.
Actually, 35 and 40 respectively.
Thank you. I didn't want to push it past safety. But what I've done is I've been plugging in a 19-volt laptop power supply into the power jack, and that's how I get more power out of that FET.
I'm liking it.
Yeah.
So if you have an old Dell laptop, plug that thing in.
Good.
Actually, I do.
Oh.
Yeah, as Phil says, you can get up to 30, 35 volts, and with more voltage, your 510 amplifier will put out more oomph.
Okay.
Can you guys see
Full
this?
power.
Can you guys see me holding this up?
Yes.
This is a camcorder battery that I've used to power it. A DC 168 camcorder battery. Yeah, that's one power supply that I've used on this transmitter. Here's another another option. It's a collection of 8 double A's with a cable on it. I can plug that in to get 12 volts out of this. These are lithium batteries, so it's less than 12 volts, but that works. But the latest one I've got is this one. And this is 4 18650s. These are the same batteries used in Tesla Model S and Model X cars.
Must be fast.
And so this gives me about 16 volts, and I got 1 watt of output signal from this transmitter using this. But you have to end up buying the holder, and you have to solder on
They're $50 a piece.
On a plug. What?
They're $50 a piece.
No, they're not. I don't remember what I paid, but they are expensive compared to others.
Just using Tesla's cost.
Oh, hey Neil, just find a parked Tesla and remove 4 batteries.
There you go. Yeah, yeah.
Well, you can get them out of Mike's car.
Anyhow, yeah, the batteries are a little more expensive, but they hold their charge unbelievably. I mean, I've had them for months and I haven't lost any charge. And I bought them with a charger. So anyway, that's one thing. Okay, at this point, I'm not going to keep talking. Does anybody have questions about assembly? Anybody having any problems? Have you started? Imagine most people haven't started yet. They're just thinking about it.
You know, John's completely re-engineered the thing by now. He's been working with the author of this particular project and analyzed the filter network and all kinds of interesting stuff.
I've not gone that far. The filtering simulation was done by Wilson and I think Joe. I was just messing around with the firmware and making some QSOs. I've actually made 2 contacts with it so far.
One to where's that place down south? Clovis, and the other one a little bit further south of that.
Santa Clarita, you said, yeah.
Santa Clarita, there you go.
11.
And then on Reverse Beacon, they heard me out in Utah and Washington State.
Wonderful.
So.
And what antenna are you using?
Well.
Oh, that's the trick. My antenna is a 80-meter horizontal loop up around 30 feet with a ladder line. So it's, Carol will tell you, you need the most efficient antenna possible to get the minuscule wattage you can generate out over the air.
And you're broadcasting on 80?
40.
Oh,
40 meters. But the signal reports out of Reverse Beacon has been pretty impressive. So hats off to you, Phil. And, you guys have a good layout. I did do one thing, Bob. I changed the switch from that little slide switch to a toggle.
Yeah.
Because it was too hard for me to hit transmit and receive with a small slide switch. So I put a bigger switch on there.
You know, that's a great idea. I didn't do that only because I didn't have a footprint in my CAD package for a regular toggle switch.
Mm-hmm.
So I took the easy way out. I'm glad you saw fit to make the change.
Well, it works a lot better. Otherwise, I'm sitting there, can't answer a QSO because they're starting to transmit while I'm trying to flip from transmit to receive.
Is there a special type of switch that you use that will fit the footprint?
Okay.
Yes, there can be. So Phil has the artwork to do that if he. I think if you pay him an extra bottle of scotch, he might lay out another board with a bigger switch.
He likes martinis.
Oh, martinis.
No,
Okay.
so do I. But you're not using the standard. You didn't just use the standard board and replace the switch then.
Oh, I'm using exactly the board that they gave me. Let's see. Can I focus this?
You have to put it in front of yourself, otherwise the background will catch it.
Yeah, let me get rid of the background.
It's okay now.
Hang on for a sec. You can see it?
No, yes.
Now, yeah, we still got
Yeah, it's
background.
okay.
Let's see. Let me get rid of the virtual background. Okay. So
This is good.
what I did was I left the original switch in there, and I just drilled some holes on the back.
Yeah. Yeah.
And wired in the bigger switch because I didn't want to disturb the beautiful tuna mix.
Did you epoxy the switch to the?
I did not. I just soldered it to the background plane.
Gotcha. All right.
That's a good idea.
I was looking for the U2. Is it this device that's next to the relay?
It's a little tiny TO92 package. Looks like a transistor package.
It's down in
I'm
the
not looking at the part. I'm looking at the placement. It
If
says
it says U2, you found the spot.
It says U1 over on the side, but there's no nomenclature.
U1's the larger regulator. U2 is a smaller one. It looks like a small
Tiny?
transistor.
That's U1 right there. This TO220 package. That's
Yeah.
U2 right there. That tiny one.
They're right near each other.
Oh, whoa. Okay. It looks more like a transistor.
Yes.
Exactly.
By the way,
Okay.
that U2 won't fly at 40,000 feet.
Stick it in your pocket, maybe.
They get shot down. Yeah, you're right.
Yeah.
Phil.
Gary Powers or whatever.
Yeah.
Okay, now I found it. Yes, so it has the transistor footprint. Okay. I was looking for it to be the bigger package because I hadn't emptied the bag and looked through it.
Michael up in Washington, did you get your package?
Yes, I did. I just got it in the mail today.
Okay,
I'm so
great.
sorry I was late, but thank you guys so much for sticking with me here. This is awesome.
Well, wait till you get finished. You may not agree.
Oh, I'm gonna have a good time. I downloaded the Arduino code and I have one of those SI535 boards already, so I was just playing with that. It's gonna be fun. To be honest, the hardest part for me now is I have to put my antenna back up. I just moved here about a year ago, and I haven't really put an antenna out yet. But this one I'm gonna spring something up in the backyard.
Didn't you explain to your wife that the antenna comes first and the furniture is second?
Well, we already had a discussion because there's a couple of power lines around here, and she came to buy the house. We came from South California, and she kind of came up here and got our house and everything. And it wasn't my first pick, but the dog really likes the yard, so I guess I got outvoted. The nice thing about the QRP stuff is you can throw a wire up anywhere and get on the air.
Right.
So Carol just sent over a schematic. You're on mute, Carol.
Yeah, I just have a question. I'm thinking of trying to use this on more than one band. And I noticed the only thing that really changes is just the values of the low-pass filter. And if you were to build a few of these low-pass filters and just put like a switch to switch the one that you're using, would it be easy to reprogram the nano so that you could then go from, say, 80 meters to 40 meters just by switching the components, because all the other parts are common. So it's just you need separate low-pass filters.
Yeah, it's a couple of inductors and some different capacitor values.
Could you socket? Could you socket the ones that vary so that you could just plug in the variables?
That would be an option as well.
That would be the smart move. I've got some little tiny pin connectors that actually solder to a board, and you can plug components into them.
Uh-huh.
And it'd be a simple matter to just put those where those components go, and then you can change them out.
Hey, ladies and gentlemen, we have 10 minutes to go.
Okay. I wanted to show something here.
I have a question for Dave Crocker. Did you get your kit? I guess he stepped away.
Yeah, I did. Thanks very much.
Okay, good,
It
good.
arrived on Wednesday evening, actually.
All right, good.
And looks like everything's in there. I took a look at it, but I haven't done much more than think about it.
Good.
This one I'm showing here is just the different low pass filters, so the different values, and you just have to switch those or plug them in separately for each band.
Sure,
And then
that'll
you would,
work.
I think, yeah, the thing is that the Arduino Nano is that programmed only, it's programmed to come up on a frequency like the QRP frequency on 40 meters.
Right. You could program
Is
it to
it
come
easy
up
to
on any
change it?
frequency, and then you can change it manually from there.
I see. You'd have to do that in the software though to make it come up on a different band.
Yeah, if you wanted to do that, Carol, I would recommend using a triple throw switch, so that when you switch bands, you also tell the Arduino which band you're on, so that it starts up with the right frequency.
Very
Otherwise,
good.
you'd be turning that up for about a half day to get to.
I imagine so. Okay,
Right.
thank you.
Right.
Is there a consensus on what band would be most useful?
Whatever you like.
I'm biased, Neil. I built it for 40. I think everyone should build it for 40 so we can get on to 40 meters.
Okay.
I'm the same
Makes
way,
very good
John.
sense.
Yeah,
I
mine
want
is
somebody to talk to.
3 of us
Well,
have 40 meters operating on 40 meters already. Yeah.
I was just thinking, with the band beginning to open, wouldn't 20 be long-term better location?
It might be, but 20 meters is awfully crowded. So if you're not banging away with high power, 20 meters you can very easily get lost in. Whereas 40 meters is, 7.040 is a pretty well-respected QRP frequency.
And during the daytime, it's very possible we can hear each other on 40 meters
Exactly.
with NVIS.
The other band I would recommend, Neil, if you wanted to do it, is 15, because there's a QRP/novice segment on 15 that would work pretty well. I like 20 meters, but 20 meters, if you're not transmitting with high power, you'll get drowned out.
Thank you.
My opinion.
Well, who's having trouble putting this thing together? Maybe I should rephrase. Who's afraid to start putting this thing together?
Biggest problem I had was trying to read the identification on the small capacitor. I had a hard time.
Just
Don't
thinking
you have
how
a
easy it's
neighbor
going to
that's
be.
about 9 years old?
I'm sorry?
Don't you have a neighbor that's about 9 years old? They got the eyes of an eagle.
Yeah. No, I got it. I got big magnifiers. So we're
So this is how I do my.
You know, you got a 20-cent problem with a $300 solution.
There you go. But
Yeah, you can get
this
a
is
little-
how I do small work.
You can get a little box for less than $20. That'll tell you what components you've got, no matter what it is: inductor, capacitor, diode, transistor. The silly little thing, you plug it in, it gives you the value.
Yeah, the only problem with some of those is when you get down to these small values, they just don't measure well.
Right, right. Below 25 puffs, it won't measure. So you just put it in parallel with 100.
You're talking about this thing.
Yep.
Right.
Well, yeah, exactly.
Yeah, that works pretty well. But if you can't read the small print, Neil, this microscope is only $100, and I use it for surface mount as well as things like this.
Hey, Neil, why don't you tell John about our experience with your rig?
Well, you did it. Well, well, we have such a short time. He had to replace the battery for my IC 7300. It's surface mount and so tiny. I cowered. I didn't do it, and then Phil was kind enough to do it.
It's about the size of a 632 screw, the head of it.
Well, I have a question for you guys, you ladies and gentlemen. Should we have another meeting next week?
Sure.
To discuss problems? Yeah.
Sure.
Well, I still would like to see the hands of those who have actually started putting this thing together. I know that John's got his done. Mike's been involved. Hiroki got started. Anybody else? Doug? Oh, and Neil.
I sent out a poll asking the question, you know, who has started soldering?
I'll pick up my unit from Phil this Saturday. Maybe I'll start Sunday.
Okay.
Good, Jojo.
Does anyone have a question if they have an appropriate soldering iron? That's a question.
Yeah. What's the wattage you recommend?
I've got two here. These are very cheap. One is 30 watts, one is 40 watts. These what do you think about that, Bob? I've got one that's temperature control, but I'm showing you the cheap ones that I have.
Yeah.
Well, 40 watts would be good. I use a fancier one myself, you know, thermostatically controlled or whatever you call it, you know.
Yeah.
Does anybody have a question about the soldering iron they have, if it's appropriate or anything like that, and like the tips?
I've got a question. I got a temperature controlled soldering gun iron, whatever, a couple of weeks ago. It came with a roll of solder, but the specifications are nothing like what you mentioned, Bob, 6040, and I'm wondering if it's okay to use.
Rojas.
Okay.
You want
6337 is nice because it has good eutectic properties. It solders well. It's what we use for building stuff commercially.
Marty, you had a question? No, I was good. I just looked and see what my wattage of my soldering iron was. It's 40 watts.
Yeah, that sounds about right.
Okay.
Trying to show I've got the solder they included is tin 99.3% copper 0.7.
Ooh.
Oh, it sounds like he's got unleaded.
You don't want that. You don't want that stuff.
Yeah.
I don't think so.
Don't even try.
It takes extremely high temperatures to work with it, and it's really, really hard to work with. You want to get some regular 6040 or what is it?
6337.
Okay.
Something like that, because that stuff's awful.
Good. I'm glad I checked that out. I was.
Yeah,
That was a good question.
Mike, just run down to Radio Shack.
Yeah, right.
Yeah.
That could be a long run.
Yeah, that one works well with the old Weller gun, you know.
I'm not even sure of that. You know, Stanford University had all their labs using that non-leaded solder.
Mm.
They had a policy on campus. You couldn't use anything lead. They changed the entire campus policy because it was so hard to work with that solder.
Mm. Interesting.
Trash can.
Okay. Very good.
This is a nice little helping hands. I picked this up at Prize last year, I think it was, and it has a nice lid magnifying glass that helps a lot.
Mm-hmm.
And I have this old roll of rosin core solder. 6040. I got this at Radio Shack.
Way back when.
Yeah.
And it
6040
still works
works
well.
fine.